Okay. So yeah, good morning and good afternoon, everyone. I hope you are not feeling sleepy after a tea session. So let's get started with the today's agenda. I would like you to think of an app that never freezes, irrespective of how many lists you are rendering, how many searches you type, or how many clicks you did. Yeah, that's the React Fiber for you. It breaks your task into chunks, prioritize your task, and make your UI smooth and accessible. So today we are going to discuss how React Fiber work under the hood, and by using its feature, how we can create lightning fast modern web app. Okay. So before diving into it, let's a small intro about myself. I'm a front-end engineer too at Cash Free Payments. I'm a part of core PG team, and apart from it, I love playing around with React internals. So with that, let's get started with our Fiber. First of all, we have to ask ourselves, why Fiber? Why do we even need it Fiber in the first place? So for understanding this, we have to understand how React used to render your component tree before React Fiber. So it traverses your entire component tree whenever you make any changes to your state and props, and it uses deep DFS to compare your old virtual DOM with the new one, and it apply all your DOM changes in one go. Hence, it will pause the browser from doing other stuff. So, do you see the problem here? The first one is no preemption. That means if React start your rendering task, it won't stop. It won't stop till it render your entire update. So let's understand this with an example. Let's say you have a search box and a long list of item. Now your long list is rendering, and a user clicks on the input box. So there user feel laggy because a long list is rendering. Since React has started the task, it won't stop in between. The second one is deep stack calls. That means it goes all way up to the down to check to compare the nodes, and hence the browser lost the control. The last one is blocking update. That is, browser will not have the control while it is painting, since this goes in all go. Let's understand this with a real world scenario. Let's say we want to create a multi-cuisine meal, and we have our two chefs, the old chef, which is our stack reconciler, and the new chef is our React Fiber. So what will our old chef do? It will start cooking one by one. It won't stop. And if any dish got delayed, the entire meal will be delayed. Hence, the user will be frustrated. User will be hungry. Whereas in case of our new chef, it can prioritize dishes. It can pause cooking to serve appetizer and respond to the special request. This ensures that user have something on their plate before like any complex food is being cooked behind the scene. So this smoother dining experience, where kitchen you can think of it, a browser remains responsive even during the complex meal preparation. Now we know why React Fiber. Why do we need it? But what the heck is this React Fiber? So React Fiber was a complete rewrite of old stack reconciler algorithm back in React 16. It had three major agenda. The first one was incremental rendering. That means it will break your task into chunks and process over multiple frames. The second one is prioritization. That means it will handle urgent tasks first and defer the less important work. The third one is concurrency. That means it can pause your rendering task, start or even abort your rendering task. We will go deep into all these fundamentals, but first of all, let's understand how Fiber node look like. So Each fiber represent a unit of work. That means every work, every update, every work that you define in your React component is a React fiber. And each fiber is connected with the other fiber in the component tree to create the entire fiber node structure. It has two major functionalities. The first one is the core properties. That means what this node contains. So this fiber node has type property. What are the type of this node? The second one is key, which is a unique identifier of that fiber node. The third one is the state node, which is how it is, like what are the state it holds. And the second one is the tree structure. That means how this node is connected with the other node in this component tree. So it has 3 pointers. The first one is return pointer, which points to the parent fiber. The child, which means the first child fiber. The sibling pointer, which points to the next sibling of the fiber node. Let's understand more this with example. Let's say we have our component structure on the right side with div as key root, and it has two children, span 1 and span 2 with the key, right? And on the left side, you can see how this fiber node is connected with each other. The div is connected to span 1 with a child pointer, and the span 1 is connected with span 2 with a sibling pointer. And now these two, span 1 and span 2, is connected to the root fiber with the help of this return pointer. This is how a full-fledged fiber tree gonna create. So if you want to understand in a plain simple term, so everything that you define in your JSX is a React fiber object, which holds what is the type, what is the unique identifier associated with it, and how it is connected to the other fiber object in the tree. So this is about the structure of the fiber node, right? But how this is connected, like when it will get rendered on the UI. So for that, we have to understand these two concepts. Like we have double buffering, which has two major properties, like the current tree and the work in progress tree. So what are these? So the current tree is actually what you see on your UI. It is the live UI that you see on the screen. It can't be changed. It is uninterruptible. Whereas work in progress tree is exact replica of your current tree. It can be changed since React has created this work in progress tree in memory. So this is where we update all our changes, whether to create node, append node, or update node. The next one is work loop phases. This is the way React renders your UI on the screen. It does in two phases. The first one is the reconciliation phases, and the second one is the commit phase. So what is happening in reconciliation phase? That is the render phase also. Whenever you update any state, it will trigger the render phase. This will clone the current fiber tree, then run its render function, then compare the old versus div, and a full-fledged work in progress tree is created. And all this process is interruptible in nature. That means React can pause this steps, render phase, and give back power to give back control to the browser to do other stuff. We will discuss that in later phases. Once this work in progress tree is ready, React immediately moved into the commit phase. So this is where the commit phase start looking into the effect list, that what are the changes being happened in the node. So it will look into the work in progress tree and calls all the updates to the real DOM, and this is happening in parallel. So it clears the work in progress tree from the memory. At the same time, it updates the root. That is where the changes are happened. So now at the end, UI shows the new state. Now this commit phase is non-interruptible in nature. Once React start this commit phase, it can't stop it. So the next one is, as we saw in the reconciliation phase, like we will be majorly covering the render phase, since this is the crux of React Fiber, because this is where our control, like we have the control. So first of all, we have to understand how this diffing work, like how they compare one node versus the other. The first one is the same type. So React will look, okay, I have div, and the second one is after update is also a div, but the style is changed. That means it will keep the node and it will only update that property. But if it is a new type, let's say we have changed the div from div to span, then it will destroy the entire subtree and create a new subtree from there. The third one is key. As we all know, React remembers the ordering of the list you render on the UI. So if the key is not present, that means React does not have a context in what. So every time you make any change, it will re-render the entire list again. But if you intelligently assign a unique key, that means the React will remember the ordering and only update those list item that is being changed. So now this is the diffing basic. But what is happening in the reconciliation phase? Let's understand. Let's go a little bit deep inside the reconciliation phase. So reconciliation phase, on the top level, call these two functions, begin work and complete work. These two functions are recursive in nature. The begin work is like works as a top to bottom, whereas the complete work works as a bottom to up. So begin work will process your current node and create, like, call the begin work again for a child till it processes. So this begin work is responsible for collecting all your effects. It won't create your work in progress tree, whereas complete tree will look into all the changes that is being provided by the begin work. So and create the updated node in the fiber tree, and at the end these two will collectively create a work in progress tree. So this was the reconciliation phase. The next one is the commit phase. So after reconciliation is complete, React enter into the commit phase, and this commit phase changes are like the entry point for this phase is commit root, like which processes the effect in three phases. The first one is before mutation, like it will collect all the state of the current DOM if needed. And the second one is mutation. This is where the insertion and updation of node is being done on the real DOM. The third one is layout. This is where the UI get painted and work in progress tree get cleared from the memory. And remember, this commit phase is synchronous and uninterruptible in nature. That means React will complete all the layouting thing without stopping. Now remember, we discussed like Project Fiber has three major functionalities. The first one was priority. But how React knows that this task will get higher priority? This task I'm talking about update, any state change. So scheduler and lanes comes into the picture. So you can think lanes as a multiple channel with the priority associated with it. So that means, let's say I have done a click event that updated a state change, it will move to one channel. So whenever a React scheduler comes to pick the updates from this channel, it will first check the priority list. Okay, this updates have a higher priority. I will pick this, and if it is doing some low priority task like prefetching the data and all, it will abandon the task and go for the higher priority task. So what are these lanes? How React will assign all this? So these are the 5 lanes. The sync lane, which is the immediate, that means if you add your updates into the sync lane, that means it will immediately get invoked into the render tree. The second one is input discrete lane. This is for all the input, it will all for the input user interaction events. The third one is default. This is for data fetching and all. Like if you do not assign or wrap your updates into any scheduler, then React will assign this default lane. The fourth one is the transition lane. This is a non-urgent UI. This we basically, as in the React 19, they have introduced start transition hook that will mark any expensive rendering task as a non-urgent task, which will not hamper the user interaction. The last one is idle. That means it has the lowest priority for the rendering part. So how React assign this? So React first of all check whether the update has start transition or not. If it is a start transition, then get the fourth lane. If not, then it will give the default default lane. But if you explicitly assign like a flush sync or use scheduler callback with idle property, then it will mark all those lanes, all those updates to the respective lanes. So that means default lane will be the default priority of any update that React will assign. So the first one is input handler. So whenever you click on any button that will change the UI, it will get input discrete lane. That means the second priority. But if you want that things to happen fast, like you want React to pick it on a priority base, you can wrap it inside the plus sync function that is being provided by React. Now the second one is animation and input. This will get the input discrete lane. That means if you do not assign any function, it will get the input discrete lane. The third one is the default lane. So the input discrete lane will assign to only input events by default. By default, all the input events will get input discrete lane. The third one is our default lane. So let's say you are updating any UI, doing any set state, that will immediately move to this default lane. The fourth one is transition. If you wrap your update under start transition, that will goes to this. The last one is the ideal lane. This you have to wrap your updates with scheduler callback with idle priority. So all these lane prioritization enable React to make intelligent decision. Like it will interrupt the low priority task with the higher priority task, so that the most important interaction feel instantaneous to the user. So the second feature that we discussed for the React Fiber was it will break your task into chunks, right? So let's understand this with example. So that term is called time slicing. So what is the life without time slicing and what is with? So as you can see in the example, we have expensive filter. So that is going to like fetch or list a large list of data. So this filter, whenever the React see this state, since we are not wrapping anything here, it will start executing. It will got the default lane. It will start executing since default lane have the higher priority. But whereas in case of time slicing, we have wrapped that start transition. We have wrapped that expensive filter under the start transition. That will mark this expensive filter as a less priority. That means if any urgent task comes, React will immediately stop this expensive filter updates and do that task on priority. But how React does this under the hood? Like how React pull this off? So first of all, it do in 3 phases. So first one is scheduler deadline. That means React scheduler keep track of each update that you do on the UI. So that means it can pause while processing. So once the updates are done, it will ask the browser, do I yield to the browser? That means, can I give control back to you? If yes, then it will stop the rendering, the reconciliation phase, and let the browser handle all the painting part if there is any priority task come. So this incremental rendering approach is what allow React to keep your app responsive even during complex update that would otherwise block the main thread. Let's say if React scheduler won't call your browser before every update. That means if any priority task that like user interaction comes, it will deprioritize the task. So that's why scheduler, yield, decision point, and browser interaction, all these phases are responsible for breaking down your work into chunks and then rendering into a different phases. The next one is the concurrent rendering. all the concept that we read till now is combined give you the concurrent rendering for React. So for the first one, that is scheduler plus lane, here the updates are tagged with lanes representing different priority. React scheduler intelligently select the highest priority lane to process the process first. Now in the render phase, so every time you see React is doing two tasks. It is rendering your UI tree, whereas it will also keep in check the browser. Do I need to give control back to you or not? So in the render phase, while begin work on each fiber node calls, after each fiber node is processed, React will call this should yield to host function to check if browser need the control or not. And the fourth one is commit phase. This is atomic. This is like we can't do much here since this is synchronous in nature and non-interruptible. So here work in progress completes, commit root is executed and all DOM mutation are done. So at this phase we have to make sure that our work in progress tree is in a much optimized way. Like we are not doing unnecessary render or changing like a list. We are not assigning some random key to that. And the fourth one is API integration. So by using start transition, that will help the React to mark any expensive or complex task as a lower priority, will help React to interact with the browser effectively. That means browser will do the important task first, then the task which is marked in start transition. And the second one is suspense. Suspense allow the subtree to pause rendering until we get the entire data. So these two create a very prioritized rendering experience. So till now we have learned how React fiber work, what is the React fiber, and how we can how we can understand different phases of React fiber. But as you can see, the rendering phase is the most important phase in the React. So it is our duty to make sure that this rendering phase is optimized as much as possible. For that, as you know, the IDs are the top priority, because what can hamper your UI is a long complex task or listing down a long list. So effectively assigning a unique key to each list will help React to not re-render the entire tree for that. The second one is, as render phase is expensive, so try to use React memo and use callback as much as possible, where you think you can stop this rendering cycle, like you can stop the number of rendering you do. The last one is use of transition. Wherever you feel that this task is expensive and it gonna block my UI, wrap it inside the start transition. That will help browser to do the most important task, which is the user interaction first. So with that, I completed my talk. Thank you so much. And I follow all these resources to learn more about React Fiber and all. If you have any question, feel free to reach out to me over my Twitter account. Thank you so much.